Good morning, class. Today we are going on to section 7.2 of your textbook, and that is found on page 230 of your textbook. Okay, so please turn to page 230. We are going to learn about area of triangle. Okay, area of triangle. Now, the formula for area of triangle for this section is found on page 232. Okay, now in primary school and in the lower secondary, we have already learned that area of triangle is half times base times height. Okay, now today we are going to introduce to you another way to write this area of triangle. Okay, area of triangle is half AB sine C. Okay, now what do I mean by that? If I have a triangle this way, the side opposite capital A is little a, the side opposite capital B is little b, and the side opposite capital C is little c. Now, if I want to find the area of this triangle, I just need to know the two sides here and the included angle. The included angle. Now, what do you mean by an included angle? That means it is the angle that is sandwiched between the two known sides. Okay, I will tell you how to apply this formula in the subsequent sections. Okay, now, first of all, let us see how is the formula related to half times base times height. Okay, half times base times height. Now, if we have a triangle and it's 90 degrees here, and we know that this is 4 cm and this is 3 cm, how do I find the area of this triangle? Now, many people will tell me is half times 3 times 4, which will give me a 6 cm square. That means it's half times base times height. Now, if we apply the formula that we have just learned, note that this is a side that we know, and this is the included angle. So we'll have half times 3 times 4 times sine 90 degrees. Now, if you press the calculator, sine 90 degrees is actually 1. So if I multiply it out, I will get a 6 cm square, which is exactly the same as the formula that we have learned, half times base times height. Okay, so actually this half times base times height comes from here, whereby this angle is 90 degrees and is sine 90 degrees and is equals to 1. So when we have a right angled triangle, there's no need to apply the formula. We just take half times base times height will do. Okay, but if the triangle is not a right angled triangle, then we will have to apply the formula as we have just learned. Okay, now I'm going to example 4 to show you how do we apply the formula. Okay, how do we apply the formula? Okay, now let's take a look at example 4. They ask you to find the area of this triangle. Can you see that these two are the sides given, and this 43 is the included angle. So I will have half times 12.4 times 9.8 times sine 43 degrees. And if you key the calculator, you'll get 41.4 cm squared. So this is the way that we apply the formula if it is not a right angled triangle. Okay, let us move on. Now, let's look at example 5, which is slightly more difficult. Okay, example 5, which is slightly more difficult. Now, example 5 is shown on page 233. So can all of you turn to page 233 so that I can go through the example. Now, as you can see, these two sides are given and this is the included angle. So I will have half times 3x times 5x sine 94 degrees equals to 145, because the question say that the area of the triangle is 145 and we are supposed to find out the value for x. Now I multiply all this is 15 over 2x squared sine 94 degrees equals to 145. I shift everything over except the x square, then I take square root. Now I only take the positive square root because I know that x must be a positive number. I key in the calculator, I will get a 4.40. I will get a 4.40. That is your example 5 that is found on page 233. Now, I've already assigned you the homework in your SLS, and I would like you to look at exercise 7b, page 235. I'm going to go through the homework right now. Okay? Now, let's go to exercise 7b, question 1a. They want you to find the area of the triangle, which will be half times 6 times 9 times sine 64. You will get this answer. We just need to apply the formula straight away. Okay? Now, likewise for 1c. But 1c, there's a slight difference. Okay? Now, we know this side and we know this side, but this included angle we do not know. But we know these two angles. Angle sum of triangle is 180 degrees. So when we take 180 minus 66 minus 32, we will get 82 degrees. So area is half times 7 times 12.1 sine 82 degrees. Don't forget, the angle that you choose must be the included angle for the two known sides. Then we can apply the formula. So we will get the answer as 41.9 cm squared. So this is your 1c. Okay, let's move on to 1e. Okay, 1e shows you a parallelogram. This is a parallelogram. Okay, now for a parallelogram, you must realize that this triangle and this triangle are actually the same. So after I find one triangle, I times 2, I'll be able to get the area of the whole parallelogram. So we will apply half times 4.8 times 5.4 times sine 112 degrees, and I multiply by 2 because this is the same as this. So I will give the answer to three significant figure as shown below, 24.0 cm squared. Okay, next, I'll be going on to question number 4. Okay, question number 4. Now, I believe all of you will not have problem with 4 part 1 because it's again a straightforward application of the formula. So it's half times 28 times 16 sine 56 degrees, and I'll get a 185.70, which to three significant figure is 186 cm squared. Now, part 2 asks you to find the perpendicular distance from A to BC. So you draw a perpendicular line from A to BC. Now, note that this is still the same triangle, so the area is still the same, 185.70. Half times base times height. Half times 28 times height must give you the same area because we are still talking about the same triangle. Okay, now I simplify, I can get H using the following calculations, and I'll get 13.3 cm. Okay, so that's how we get the perpendicular height from A to BC. Now, the important thing here is that we must know that it's the same triangle, and the same triangle must have the same area. That's how we apply the formula over here. Okay, now for question number 5. Alright, they ask you to find the total area of the two estates. Now, this is made up of two triangles. I just need to find out the area of one triangle plus the area of the other triangle, sum them up, I get the answer, and I change it to three significant figures. That will be your answer to question number 5. Just find out the two areas and add them up together, you will get the answer. Okay? Alright, I'm moving on to question number 6. Number 6 is similar to one of the examples that I've done just now. Okay? The question says that the area of the triangle is 97 and the value of x is to be found. So, I just plugged in the formula. do the necessary calculations, take the positive square root, and the value of x will be 3.23. 3.23. Okay, you just have to get yourself familiar with the formula of the triangle will do. It's half times the two sides that you know and times sine of the included angle. Okay, so this will be your question number 6. Alright, I am moving on to question number 7. Okay, I'm moving on to question number 7. Alright, this is question number 7. Now, question 7 says that find angle BAD. Find angle BAD. Now, I want you to take note. BAD is this angle here. Okay, now I know this is 30, this angle will be 60. I know this whole thing is 90, therefore this is 30 degrees. Okay, so I can get angle BAD as 30 degrees here. Okay, this is your part 1. Let's take a look at part 2. They want to find the length of BD. BD is here. Okay, now I need you now to look at this triangle here. Alright, this is the opposite of 30. This is the hypo, so I'm using sine. Sine 30 is BD over 20. I do the necessary calculations. I will get BD as 10 cm. Okay, now finally I'm going to find the area of triangle ABC. I need to find this whole triangle ABC. Now class, you notice that this is 90 degrees. If I'm able to find AC, I can just take half times base times height. Half times 20 times AC. Now in order to find AC, I have to find AD. Okay, I use Pythagoras theorem, I get AD. Okay, I get AD. Then I use sine of ACD, which is opposite over AC, opposite over hypo. Okay, this angle is 30 degrees. So I bring over, I will get AC as 34.64. Okay, I repeat. I get AD by using Pythagoras theorem. Then I'm able to use AD and sine of 30 to get AC. Once I've gotten AC, I just need to use half times base times height to get the answer as 346 cm squared for the answer to the triangle, the area of triangle ABC. Okay, now this is your question number 7. I'm moving on to question number 9. Now, question number 9 seems rather difficult, but actually we just have to make sure we know one thing and let it be X, and we can get the answer straight away. Okay, now let's take a look at this particular question. Now the question say 3QR is 4PR. We let QR be X, so we put X over here and bring the 4 over here. So PR becomes 3/4 X. Now these are the two sides, this is the included angle. So half times X times 3/4 X times sine 55 is 158. 158 is the area of the triangle as given in the question. So I do the necessary manipulation. I get X, take the positive square root, then I will get QR as 22.7 cm. That's how we find the answer to question number 9. Okay, now there is an extra question that I would like you to try it in your notebook. Okay, and I'm going to give you just some hints here. This is the extra question that I want you to try. Question number 8. Okay, now the question did not give you a diagram. They say that the diagonals of a parallelogram have lengths 15.6 and 17.2 cm. They intersect at an angle of 120 degrees. Find the area of the parallelogram. Now I'm going to explain to you how we do this particular question. Now, for a parallelogram, the two diagonals bisect each other. That means they divide each other into two equal halves. So if one diagonal is 17.2, half of it will be 8.6. If one diagonal is 15.6, half of it will be 7.8. Now, I am going to find the area of this triangle, which means I'll take half times 7.8 times 8.6, sine 120. Note that this and this is the same. Okay, this triangle and this triangle is the same. So I will have to times 2. Now, next, can we look at this other triangle? It will be half times 8.6 times 7.8 sine 60 degrees. And this triangle is again the same as this triangle. So if I can find the area of this shaded triangle, I times 2, I'll be able to get the area of the whole parallelogram. Okay, so what I did is I find out area of A, which is this, area of B, which is this. Okay, then I add them up and I multiply by 2 because I still have this side, and I will get a 116.18, which when rounded off to 3 significant figure is 116 cm squared. Okay, so the important thing for this question is you must draw the diagram to visualize, and after that to do it slowly using the area of triangle formula. Okay, now I have already gone through the whole part of this section, and I just want to revise the formula with you. For area of triangle is just half AB sine C, where AB are the known sides and C is the included angle of A and B. That means it must be the angle sandwiched between the two known sides. Then we can apply the formula. Okay, so this is all for the section for 7.2, area of a triangle. Thank you, class.